Solar eruptions, a fascinating yet complex phenomenon emanating from the surface of the sun, can have a significant impact on our planet, albeit indirectly. The sun, that incandescent star at the center of our solar system, is a constant being of nuclear activity. Solar eruptions represent a sudden release of energy stored in the magnetic fields protruding from sunspots. This is the result of a rapid increase in the magnetic field that may have been accumulating tension. When a solar eruption occurs, charged particles are emitted into space at dizzying speeds. Within minutes, this coronal mass ejection, as it is often known, propagates towards Earth. Most of the time, our planet dodges these solar storms thanks to its magnetic field, a natural shield that protects us from dangerous particles. However, the impact can be significant if the eruption is particularly intense. By interacting with Earth's magnetospheric and atmospheric systems, these particles can trigger displays of luminescence, better known as auroras, in regions near the poles. These dancing lights are merely a visible manifestation of broader invisible processes. The true impact of solar eruptions, however, is more palpable in terrestrial technology. The intense interaction between the particles emitted by the Sun and Earth's magnetosphere has been shown to disrupt the functioning of communication and navigation satellites, generating disturbances in GPS signals and radio transmissions. Power lines are also at risk, with the possibility of surges that could lead to temporary blackouts. Even more concerning, the additional radiation that solar eruptions emit can endanger astronauts, as well as passengers and crew on commercial flights traversing regions near the poles. This is why monitoring space weather has become a priority for space and meteorological agencies. Finally, while these events are inevitable and part of a solar cycle that fluctuates every 11 years, our understanding and preparedness for their effects is crucial. Technology continues to advance, and with it, the methods to predict and mitigate the effects of solar eruptions on Earth. From recognizing previous patterns in the sun's behavior to developing satellites with magnetic shielding and early warning systems. The knowledge of the real impact of solar eruptions is constantly evolving. In summary, although the direct impact of solar eruptions on terrestrial life may seem intangible and sporadic, the indirect consequences on our technological systems are significant. This area of study continues flourishing in a collaborative effort around the world in response to the forces of the universe that we have little control over.